Alright, we're going to start our new unit, and our next unit is on how can we use derivatives to help us solve word problems and applications of derivatives and different types of things that derivatives will allow us to do in terms of practical, real-world type applications. So our first lesson is going to be on using derivatives to find max and min word problems. You've learned these already in Math 20, so we're just going to use it from a derivative approach as opposed to a quadratic graphing approach. So for example, in Math 20, you might have done questions where we had a farmer wants to make a field divided into sections, and he wants to have the largest possible area or maximum area based on a certain amount of perimeter. So suppose he has 100 meters of fencing, what would the dimensions of this field be to get the largest possible area? So those were common questions. We'll look at one of those in a minute. Maybe another one that would have been done would have been something like a band can sell 500 tickets at $10 a piece. But if they increase $1, then they get 25 fewer tickets or fewer sales. So the question would be, what would be the best price to charge in order to get maximum profit? So those ones were quite common too. Maybe let's do this one. So if we had $500 or 500 tickets at $10, we would just multiply those to get a $5,000 profit. So if we have 500 people, but if we increase it by $1, we lose 25 people per dollar. So we call X our number of increases. So then our money would be 10 minus 1x. So that should give us our profit. So in order to calculate the maximum profit, we need to be able to do the derivative of that equation. So let's FOIL it out. Let's write it up here. So if we FOIL out that equation, you'd get 5,000 minus 500x minus 250x plus 25x squared. So if we simplify the 2x terms, we can make that minus 750. Oh, that should have been a plus in the equation. So that would be, let's fix this. So that'd be plus 250 here, and then it'd be a minus x squared at the end. Okay, we're increasing $1, so that'll be plus on the price, but less on the people. Okay, so that should work. So we should have minus 250x minus 25x squared. So now if we're trying to calculate the maximum, remember maximums and minimums occur when our derivative or slope is equal to 0. So let's do our derivative. So that'd give us negative 250 minus 50x. We're going to make that equation equal to 0. And something's still not quite right. Okay, I figured out the mistake again. So I did do the foiling wrong originally. So we should have had, let's change the colors here. So when we FOILed it out, it would have been plus 500x and minus 250. So that would make that a plus, that would make that a plus. Now we're in business. So when we solve this, we'd have 250 equals 50x. So if we divide by 50, we get x equals 5. So if we take that x equals 5 and put it back into our original equation, we would have 10 plus x, so $15 is the best price. And if we did charge $15, we would get 25 times 5 is 125, so we'd have 375 people would be the optimal profit. And if the question was asking how much money did you actually make, you could go 15 times 375, and that would give you the total profit. So it should be a little bit over 5,000. Okay, that's good enough for a quick review. There was other max-min problems that you do. Sometimes it was things like find two consecutive numbers that have a maximum sum of a certain value, that type of thing. But let's go through a few specific examples, and that'll be good enough for today. So when we're solving word problems, what we want to do is sort of, you don't need to memorize these steps, but it's kind of good to sort of think about these as we go through. So what we want to do is we want to be able to understand the problem. So when I say understand the problem, what you really want to be careful of is, what are you looking for? Are we trying to find maximum area? Are we trying to find minimum profit? Are we trying to find minimum surface area? Whatever. So that's whatever the formula that you're going to be trying to solve for the max or min, that's the one that we're going to have to do the derivative on. So that's the most important thing. The other stuff, the other information they give you will likely help you solve the rest of the question. Second step, generally draw a diagram. So if we're talking about a farmer dividing a pig pen up into sections, draw that diagram and kind of have a pretty decent diagram. And then step 3, let's introduce some notations. We could call our lengths x and y or something like that in the diagram, and then from there we would come up with some sort of equation using that shape. So if this rectangle, we would have 4 x's and 2 y's. So you could see my equation then maybe is 4x plus 2y equals whatever our perimeter would be. So let's suppose in the question they told us the perimeter was 100 meters. So that would be our one equation, but again we'll go back to the beginning. We're trying to solve for maximum area, so our area would be x times y in this case. So those would be your two equations that we would be working with. So step 4 says substitute info into the equation in order to get only two variables. So we have x and y in one equation, and we have area x and y in the other. We only need two, so this is where we're going to have to plug one equation into the other to get rid of either the x or the y. And once you do that, the rest is pretty straightforward. Do the derivative. That'll give you where your max and min locations would be. Make that equation equal to 0, and then solve the question from there. Okay, so let's go through an example. So this first one, it shows we have a farmer. He wants to make a rectangular fence. My picture got messed up here a little bit. So we have a rectangle, so I got it x by y. The y is cut off there a little bit. And we're trying to figure out what is the maximum area, but this rectangle fence is going to be along a river. So this blue stuff should have showed that there was a river along here. So what that means is we don't need that third side. So you can see for our area, we're still going to be x times y, or length times width. And you can see for the rectangle perimeter, if we only have 3 sides, it'd be 2x plus 1y. And they told us in the question he has a total of 2,400 feet to make that fence. So the question is, what would be the maximum area, or what would be the dimensions to give you the maximum area? So let's solve for x, y, and the area in this case. So we've got our two formulas at the bottom. So the issue again now, once we have our diagram, we've got our labels, we've got our formulas, we need to combine them to get 1. And our goal is solve for area. So we need to substitute either the x or the y in to only get 2 variables. And it doesn't really matter which one you pick. You want to usually pick the easiest that rearrange in the one formula, but you also want the one that's going to be the easiest for doing derivatives. In this case, doesn't really matter. I think y is probably the simpler version, because we would just have 2,400 minus 2x. So now if we plug that into our other equation, you'd have x times 2,400 minus 2x. And let's FOIL that out so we don't have to do a product rule. So we'd have 2,400x minus 2x squared. So that's going to be our equation for area that we're going to need to do the derivative on. So our equation was 2,400x minus 2x squared. So we're trying to calculate a max or min, so we need to do the derivative. So that would give us 2,400 minus 4x. Make that equation equal to 0, and when we solve it, you can see it works pretty easy. We get x equals 600. So if we went back to our original picture, we had x, y, and x. So we're getting an answer of 600 for the x distance. So that means both sides would be 600. And our original formula was x plus 2y, or sorry, 2x plus y equals 2,400. So we could use that equation to solve for y. And we already had that on the previous page. I had it rearranged as 2400 minus 2x. So if we put the 600 in there, we would get 1200 for our y value. So we've got our x and the y solved, and if the question was asking what is the area, we would either just from the original area formula as x times y, we could go 600 times 1200, that would be fine. And that would give us 7200. Or we could use the area formula that we isolated. So we'd have 2400 times 600 minus 2 times 600 squared. If you plug it into that one, you would also get 72, or not 7200, 720,000 it would be. Okay, so both areas come out the same no matter which formula you use. So the issue with these questions is write your area formula, figure out the perimeter, substitute the perimeter into the area, and then do your derivative and solve from there. Let's look at one more example. So this one is a similar kind of question, except it's a different shape. So instead of it just being a two-dimensional rectangle, we're looking at a 3D cylinder in this case. So the question is saying we want to make a cylinder shape can to hold 1 liter of oil. And the question is saying what would the dimensions be that would give us the minimum cost to make the can. So we want the minimum amount of surface area is what this question's looking for. We want to minimize the surface area with a volume of 1,000 or 1 liter, and you can see at the bottom 1 liter is the same thing as 1,000 milliliters or 1,000 centimeters cubed. So we want to figure out what our radius and height would be for this can in centimeters that would give us a volume of 1,000 centimeters cubed. So the challenge for this is we have to understand and use the surface area and volume formulas, which you might not remember. So you'll get these. If it was a test or something, I'd give you these formulas. You don't need to memorize them. So our first one is volume of a cylinder is pi r squared times height. So that's the one that we know because they're given that we have a volume of 1,000. So that's the first formula that we're going to need. The second formula for surface area is we have two circles, that's 2 pi r squared, but then we get the circumference times height for the middle part, so that'd be 2 pi r h. So that's the one we're going to have to do the derivative on, because that's the one we're trying to find the minimum amount for. With these questions, you don't have to worry about whether you're trying to solve for max or min. We don't have to test. The question will tell us. So in this case, it's saying the minimum. So if we were to solve it and test that point, it would tell us that the slopes are negative and positive, so we would know it's automatically minimum. You could always check if you think you made a mistake or something, but generally speaking with word problems, we don't need to test. We just solve for whichever one works to give us a value of 0, and that's good enough. So let's finish this one off. So we know we have a volume of 1,000. So let's rearrange this volume equation. So we can either solve it for r or h. The problem if we solve it for r, we're going to have to square root it. So that's not very nice. And if you look in our surface area question, we have two different r values. So we'd have to substitute it in twice. So I think in both scenarios, the h value is the better one to solve for. So h is just 1,000 divided by pi r squared, so that's pretty easy. So now if we plug that into just our single h term of surface area, that should be the simplest possible. So we'd have 2 pi r squared plus 2 pi r times 1,000 over pi r squared. So before we do our derivatives, we can see the pi's would cancel and one of the r's would cancel. So that'll simplify things quite nice. We get 2 pi r squared, and the second part would just be 2,000 divided by r. So that should be our formula that we need to do the derivative on. So once you've substituted and eliminated one of the variables, we should be good. So let's take that area formula when r was our variable. Let's rewrite it here. So we had 2 pi r squared for the circles and then we had 2,000 divided by r for the rest of it. So all I would do in this case probably before I do the derivative is, let's rewrite it so we could use a power rule. So let's make it 2,000 r to the negative 1. So now when we do our derivative, we would get 4 pi r. Just leave the pi there, it doesn't affect anything. And then we'd get minus 2,000 r to the negative 2. And that's the equation we want to solve for. So let's rewrite it as, bring the 2,000 to the other side because it's going to be equal to 0. And let's put that r back on the bottom. So now when we simplify this, we'd have 4 pi r cubed equals 2,000. And we can divide by 4 pi. So 2,000 divided by 4 pi on your calculator, whatever that is, and then cube root it. So if we do all of that, I typed it in on my calculator, I get 5.4 centimeters for our radius. So that tells us a radius would be 5.4. So now the only thing we've got left to figure out is what the height would be. So if we go back to the previous page, we had a height, when we rearranged the equation, we had height equals 1,000 divided by pi r squared. That was from our volume formula. So if we plug this 5.4 into there, this is the easiest place to figure it out. So 1,000 divided by pi times 5.4 gives us 10.8. So in this case, we would have a radius of 5.4, a height of 10.8 centimeters, and if we plug that into our volume formula, that would give us indeed a volume of 1,000 milliliters or centimeters cubed, or 1 liter, right? Those are the same thing. So that's it. So it's kind of interesting with this one, you can see that what we end up getting for an optimal shape is a cylinder that is the same diameter as the height. So our height was 10.8, our radius was 5.4, so that means if we doubled it, we'd have 10.8 across. So what they're saying is the best type of cylinder in order to minimize the amount of material would be something that's roughly the same width as it is high. So like a big coffee cup would be probably a pretty applicable ideal cylinder. If you think of like a water bottle, that's generally a little bit too skinny, like to be optimal, but obviously it's got to be skinny for you to be able to hang on to it properly. But that's it. We've got kind of a few examples here. You can get the idea. So we need 2 formulas typically, and you'd substitute one into the other if you need to get rid of a variable. If you only had one variable, so if I said I had a question something like, let's just look at one. So if I gave you something like, if I said something like, find 2 numbers that has a maximum product. So let's call it product equals x times y. But if I said the first number plus 2 times the second equals 12 or something like that, we'd have to do the same sort of thing. Solve this equation for x or y, plug it into the product, and then do our derivative. Okay, so those similar kinds of questions, just we're dealing with numbers instead of areas or volumes, but works pretty much the same. If I gave you a question where maybe it was a rectangular cube, but I gave you all of the dimensions in terms of each other, so if let's suppose I said the height was x, let's suppose our width was double that, and let's suppose our depth of it was 3x minus 1. And if I told you to find the maximum volume, in this case, we don't have to worry about any substitution because all of our variables are in terms of x already. So from here, just FOIL it out, calculate your derivative, and you'd be good. So that one's pretty simple. So it just depends on the question, what kind of variables you have, what type of information you have. Sometimes you need to substitute, sometimes you don't, but that's basically it. One other one maybe that we can look at quickly before we stop is when you see the term consecutive integers. So a consecutive integer would be like something like 10 and 11 or 15 and 16. So if we call the first one x, the second one would then be x plus 1. Okay, if I said consecutive even integers, that means we have 2, 4, 6, 8. So we'd call the first one x, second one would be x plus 2. right? So you just got to add 2 instead of adding 1. And then from there, just follow the rest of the question. So if it said something like 3 times the first plus 2 times the second for consecutive integers, and it said what sum would make it a maximum, we would only have the one equation, do your derivative, and solve. Okay, so those are the kind of scenarios that you'd likely see. So you should be good to do the 5.1 worksheet. And that's all.